All right, so now what is the purpose of knowing measures of variation? How can they help us to create a more complete picture about a data set in addition to measures of center? All right, so the first one is we're going to talk about something called the empirical rule, which is for symmetrical and bell-shaped data. All right, so taking a look at this picture that we have here, take a second, jot down that bell-shaped curve. All right, this middle number is going to be X bar. All right, so X bar goes right through the center of the data set. All right, so there's X bar. What we're going to have is this. Oops, wrong color, sorry. This is going to be, we're going to count by the standard deviation. So if I go up by 1 standard deviation, or if I don't go down by 1 standard deviation, all right? If I cut the graph off at those 2 points, okay, this middle portion of the data, there is 68% of the data values lie between those 2 numbers, okay? So off to the side here, I'm going to write that 68% of the data values lie within 1 standard deviation of the mean. So 1 standard deviation of the center, or the mean. Okay, specifically the mean, not the median. Okay. Actually, you know what? I'm going to change that. I'm going to write of the mean. Sorry. I'm going to write that the mean is X bar. Okay. All right, so that's a good chunk of the data. It's more than half. It is a majority, all right? So then what comes next? So now if I go another line over, if I go to X bar plus 2 standard deviations, which would be here, or X bar minus 2 standard deviations, which is right here, and if I look at all of that data, if I look at all of this, that's going to be drastically more. That's actually 95% of the data, which is the vast majority. Okay, so 95% of the data values lie within 2 standard deviations of the center. So 2 standard deviations of the mean. Again, X bar. Oops, that looks a little funky. Let's fix that real quick. Okay. All right. Now, if we went for a third one, if we went for another one over here, these data values are most likely outliers on either the left or the right. Later on, after our test, we will go through and take a look at outliers in more detail, okay? But if I were to go 3 standard deviations away, now I'd be looking at 99.7%. Sorry, I forgot the 0.7% of the data values, okay? So 99.7%, all right? We're going to go with the idea of outliers are beyond the X bar plus 2s and the X bar minus 2s. Anything bigger than X bar plus 2s is going to be an unusually high data value. Anything below X bar minus 2s is going to be an unusually low data value. All right. So those are the percentages. Let's give this a little bit more context with a specific example. So let's take a look at the average, emphasis on average, adult male, and that is 69.0 inches, or that's 5'9", okay? The standard deviation is 2.8 inches. The data is symmetrical and bell-shaped, so we can figure out what are called the typical minimum and maximum value. So typical minimum, separate from the actual minimum, typical minimum is X bar minus 2s, all right? And X bar is the 69.0 minus 2 times the standard deviation they told us was 2.8. And if I do that computation, I get 63.4 inches, or 5 foot 3.4 inches. So if someone is shorter, if an adult male is shorter than 5 foot, roughly 3.5 inches, then we would say that they are considered unusually short. It's not common for that to happen, is what they're saying. All right, and then the typical maximum is the same formula, but with the addition involved, X bar plus 2S. So that would be the 69.0 for the mean plus 2 times the standard deviation of 2.8. That computation comes out to 74.6 inches, which is 6 foot, let's see, 72 inches is 6 feet, so 2.6 inches. So if someone is, say, for example, 6'3", they're considered unusually tall for the adult male, okay? So I'm just writing off to the side now that X bar was in fact 69.0 and the standard deviation was 2.8. So that's giving it some context for a bell-shaped symmetrical curve, okay? Typical min and max, okay? Not actual minimum and maximum, but typical. So anything between these two numbers would be considered an expected or a typical height for an average adult male. Anything smaller than the 63.4 or bigger than the 74.6 would be considered unusually short or unusually tall.